Ankit would have showed you the basics of image processing and imaging, and that would give you the foundation to start with. Then Nikhil, who is my colleague at MathWorks, would have given you an introduction to AI, where you probably saw something, some of the apps that are used by engineers and scientists when they want to solve AI problems. Yesterday, I think Kunal also would have shown you some application or a real practical way of doing AI, where when you're training all of these models, they have multiple different combinations of the hyperparameters. So instead of changing things one by one, can you automate some of these changes and then help that will help you to find the best model, right? And yesterday I think he showed you an example of biomedical imaging. Is this correct, more or less, like the kind of content you saw so far?
Yes, ma'am. Yes.
Okay, perfect, perfect. So in today's session, what I will talk about are biomedical signals, and I've titled my talk AI for Biomedical Signals and Images because, as you'll see the in the engineering and the science world, when it comes to signals, biomedical signals, you can treat them as signals or you can treat them as images. And that might sound a little confusing at first, but I'll show you exactly how that works. So let me share my screen. I am going to actually do a couple of hands-on activities. If there is somebody here who wants to uh, try it out and follow along with me, I'll share those files with you. If you just want to observe, that is also fine. Feel free to ask questions. I'm monitoring the chat. I want to keep this as a relaxed session where we can interact, where we can discuss things. Feel free to raise your hand to ask a question or just drop it on the chat. I can see it in real time. And like I said, if you want to follow along with these examples, I will share this in the chat window. Okay. So I've put it in chat. If you cannot see it, do let me know. But these are the files that the demos I have planned for today. Okay. Before we, okay, great. Yeah, thanks, ma'am. So before we move ahead, I just want maybe a show of hands. How many of you have a background in signal processing? If I can just get a rough estimate, then depending on that, we will either go into a lot of detail or we will keep it high level with just enough understanding to understand how this application is working. So maybe just roughly raise your hand, or ma'am, if you can give me an estimate, how many people here would come with a signal processing background?
Ma'am, few of them are from the background and few of them are new to this.
Okay, 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 sure. So what I will do is, since some of you are new, I don't want to give too much of details that will be overload of information. So what I'll do is I will describe it in enough detail for us to understand the example. If you have questions, then we'll go into the details. And after the session, on the same link, I will upload my slides. So those slides will have everything you are seeing now in the presentation, but I will also include some extra slides, which will be the explanation for some of these deeper signal processing concepts. Okay, so let's get in. Um, I'm sure that given your interest in AI, you probably know the scope of it, right? AI can be used across multiple domains. And when we're thinking of signal processing, you can use it. So in, let's say, the automotive manufacturing, aerospace industry, you can fix sensors to machine parts. And those sensors will constantly record the vibration of that machine part. So for example, sometimes when you're at home and if you have an AC, you know your AC is working fine if it's not making sound. But if it's making a lot of sound, it means that there is some issue with the AC. Similarly, with your car, sound is nothing but vibrations, and vibrations can be picked up from machines, and they can tell us whether the machine is functioning okay or there is some issue with it. Similarly, there is seismic signal analysis. So, you probably know that the earth is constantly moving. There are these tectonic plates moving over one another. Sometimes when these plates crash, it causes an earthquake, right? And earthquakes can happen on land, they can happen under the sea, and sometimes these earthquakes can be very devastating. So for example, in 2004 December, when we had the tsunami, the cause of that tsunami was an underwater earthquake near Indonesia. And that earthquake happened and it caused all of these ripple effects, including these very high waves that even came to East India coast. So geologists, seismologists, they are always studying signals to try and predict when the next earthquake will happen or when the next tectonic shift will happen, so that they can also inform people, but they also understand, how is the earth changing. Similarly, predictive maintenance, like I told you, if you monitor signals in the right way, you are able to predict when a fault will occur in your machine, in your car, in your um, AC, or even in your airplane, right? So, predictive maintenance is you're kind of trying to figure out when the fault will happen so that you can correct it before it happens. So, if I know that my car is, if my car gives me a signal that it will fail in the next 10 kilometers, what I need to do is within the next 5 kilometers, I need to find a station, park it there, and get somebody to look at it. Basically, that's what predictive maintenance is. Digital health, on the other hand, I'm sure most of us are aware. We all have phones, we have smartwatches. Um, if you're Another example is my dad is actually, he has diabetes, so he wears one of those continuous glucose monitors. Those are constant monitors, they are capturing signals. All of this data stream that we get from our phones, these are signals, and so we can use AI on these signals to predict health of a patient if something is going wrong and so on, right? Machine health I won't describe again because it kind of get, we talked about it with vibration and predictive maintenance. Now these are just 5 examples here, but obviously there are limitless opportunities, and electronics are becoming cheaper every day, so that means sensors are becoming cheaper, and so the amount of data we have access to